All right, today we talk about arrays. So hopefully everybody knows what a variable is by now. Better know, and knows how to use them, what they're used for. So we use them to store, data for use at some point during our program. We can create all the variables we want. So we know that a variable is, it's like a box, right? So it's a box. It can store certain things. We give a data type for it. It tells C# what we want to store in it. And then we have a name that we use to access it, okay? And we can assign things to it. We can, print values out. They're stored in it, all kinds of different things. So let's see, a little while back in another assignment, we had an exercise where I asked you to create a program that would allow the user to enter 10 grades. Everybody remember that one? And some of you solved it by creating 10 different variables, okay? So that gets a little old. Like, so you do something like this and double, let's say grade 1, grade 2, so on and so forth, et cetera, et cetera. So 10 different variables. So what if I had asked you to create a program that would allow the user to store 100 grades, or how about 1,000 grades? You going to create different variables for all those? Yeah, no way. That would suck. Fortunately, there's a better way of dealing with it. So instead of creating a bunch of different variables, most languages have what's called an array or arrays, and so does C#. So an array is like a big box that stores a bunch of smaller boxes, however many smaller boxes we want it to. So it's like a big box that can store multiple variables inside. The advantage is that the array has just one name that we use to access the array, and then to get to the individual boxes inside of it, we just give an index. So that would just be an integer value that is for the particular thing that we want to access. Okay? So to declare an array is going to be let's take this grade thing for example. So we're going to start by declaring a data type, just like normal, okay? And then, let's see, so to declare a variable called grades, we'd do something like that, right? All right, so that would just create a single box. But to create an array, we're going to use array notation, and that is going to be square brackets, just like so. So in C#, whenever you see square brackets, you're dealing with an array. And that right there is a valid declaration, okay, for creating at least the array name, all right, and specifying that it is to be an array. So this says grades is an array of doubles. So grades is a box that stores a bunch of smaller boxes that are of type double. Make sense? Okay, so now we're not quite there yet. To make this useful, we need to actually allocate space for it, okay? So when I say allocate space for it, I mean we need to have C# create space out in memory for this actual array. So far we've just declared a name. So to allocate space, we're going to assign, so we use the assignment operator, and then we're going to do this keyword, new, so that's one you haven't seen before. And again, we're going to say the data type followed by array notation, okay? Except that this time inside the box, or the square brackets rather, we need to specify the size. So let's just take, for example, we'll say 5. Okay? So all right, so what that says is we're going to create an array called grades that will store a bunch of boxes that can hold doubles, and there's actually going to be 5 boxes. So 5 boxes that will hold doubles, all accessed by the name grades. Yes?
Did you say that's like saying how many variables you can have?
Yes, the 5, yeah. Yeah, that's like saying how many smaller variables you would have inside this box, okay? And you can put any number you want. It's got to be an integer, okay? And it's got to be positive as well, by the way. It can't be negative. So if I want to do 100 grades, I just replace the 5 with 100 or 1,000, whatever you want to put in there. Okay, so now, this is a typical declaration, so that'll allocate space out in memory. The keyword here, new, we haven't seen before. We use that when we're creating what are called reference types, which an array is a reference type. So we have to use that. If you take my next course, which hopefully all of you will, we'll learn more about what reference types are and why we do that sort of thing. Okay? So now, we can visualize this like this. I'm going to have to do it on the board. So right there we created grades. And grades itself is a box, okay? Like a variable, actually. Except that instead of storing, you know, like a number, like a double or an int or a string or something like that, this actually holds an address. Okay, and what the address is, we don't know, we don't care, because the system takes care of it for us. But what this address does is it points to the actual array itself. Okay, so it holds the address of the first element of the array. So I created a 5-element array. We can visualize it like this: 1, 2, 3, 4, 5. So there are 5 elements out in memory somewhere. Okay, and the first element here is going to actually have index 0. So array indices start from 0. So it's going to go 1, 2, 3, 4. So an array of 5 elements is going to have indices 0 through 4. So however many elements your array has, the indices, the maximum index is going to be 1 less than the total number of elements you have. So if you have a 100-element array, what are your indices? From what to what? 100 element, what's the maximum?
9.
Yeah, 99, okay. If it's 1,000, the maximum is 999. So it's always 0 to whatever, okay? The reason why it starts at 0 has to do with indexing. So this address, you know, is right there. To get to the next address, what the language does is just adds 1, 2, 3, or 4, whatever it needs to get to the next element. Okay, so that's pretty basic. That's basically how it is. So that makes sense. Okay, so grades actually points to the first element of our array out in memory. Now at this point we don't actually have anything in it, okay, except for nulls. Arrays, everything inside of it, when you first create the array, we have what's called null stored in each one. So we want to put something useful in it, like we do, you know, normally do we've done with doubles. I mean, variables. You know, when we create a variable, we want to put something useful in it. So to put something useful in this, I can do, well, first of all, I just give the name of the array, and then I'm going to use my square brackets, but this time I'm going to give an index, and it's any one of the valid indices. All right, so let's see, if this is a 5-element array, 3 is a valid index, right? Okay, so I can say grades at 3 and then assigned. Let's say somebody made 100 on the exam, and there you go. Looks a lot like assigning a value to a variable, right? Okay, because it is pretty much, that's pretty much what you're doing actually. All right, and let's see, what if I do this? How about that? Grades at 5, assign 64. That look good? Well, it's not. It's called out of bounds. We're out of bounds because there is no element 5. All right, there's no index of 5. The maximum index is going to be, so you'd get, if I actually tried to run this, I'd get an array out of bounds exception. All right, so it throws an exception that says array out of bounds, because 5 is, it's past this, right? It's past this, and we can't go past that. All right. So the maximum index would be 4. That would be valid right there. Okay, and so on and so forth. And then if I want to, you know, so that's assigning values to 2 of the elements. I have the rest unassigned so far, but then I can do things like this. Let's see, grades at 4. All right, So I can print out a value once I got a value stored in there. Okay. If I try to print out one of the indices that I didn't assign anything to, it's just gonna print a blank because they just basically have blank stored inside of them. All right. All right. So in this example, again, we're going to create an array. This time it's going to be an integer array. All right. So an integer array called nums. It's going to be it's going to have 10 elements in it. All right. So the indices will be 0 through 9. Right here, I'm doing something that's pretty common. We're going to cycle through the array in a loop, using a loop. So in this example, and it's common to use I like to use for loops for this. And there's another type of loop we'll look at in a second that we haven't seen yet. But you can use any of the loops that we've looked at to do this. So for int I, I'm going to start it at 0 because that's where my indices start. And as long as I is less than 10, which is important, right? If you said less than or equal to 10, then you get an error because the maximum index is 9. You got to stay less than that. And then we're going to increment I each time through. So what I'm doing here is saying nums at, so the array at the current index is assigned the value of the current index. Why am I doing that? Nah, it's just for example purposes. All right. All I'm doing is whatever the current index is, I'm putting it in the array just to demonstrate. So this is not real practical. It's just again for demonstration. All right. And then this second for loop. All I'm doing, so in this first for loop assigns values. The second for loop, I'm just cycling through again and printing the values out. All right. No big deal there. So now we've seen how to do double arrays, int arrays. Any questions about that one? All right. Here, let's see, what are we doing here? So same thing. So we're creating the same array and we're going through a loop, but this time, instead of just assigning our index values, I'm actually prompting the user to enter an integer, and then I'm grabbing it using readline, converting it to int, and then storing it in nums at the current index. Okay. So nums at that current index gets whatever the user enters. All right. And then again, this for loop is just like before. It just cycles through and prints out whatever the user entered. Yes.
So you have to separate the two and then print?
What's that?
You have two for loops, so you have to make another one and one to print.
You don't. I mean, technically, excuse me. Technically, you don't have to. I could have gotten rid of this loop, and I could have put this line right under here, right under this line. I could have done that, but I'm just demonstrating. One for getting input and then one for printing it out. But no, to answer your question, this loop is not, I mean, you don't have to separate them. Now, we can also do string arrays. So this is going to create a string array called names, and it's going to be 5 elements. And here I'm filling with values. So names at 0. So the first element, I'm assigning it the value Bill. Okay, so I'm writing a string literal here, since each one of these is a separate string, and just keep on going. And then finally, I'm going to cycle through and print the values out. Again, I don't have to print the values out. I'm just trying to demonstrate. All right, but that's how you deal with a string array. No different than doubles or ints or any of the other data types. I mean, there's plenty of data types we haven't looked at, but it all works the same. And in this example, I'm just showing you that it doesn't matter what order. Doesn't matter what order we fill. So here I'm going 2, 0, 4. All right. And notice also that I did not fill out all the elements. So there's 5 elements and I've only assigned values to 3. In this loop, what I'm doing is just cycling through again, but this time down here we got an if that's nested inside. What this says is if names at the current index is not equal null. All right, so any of these, let's see, so 1 and 3 are going to have null in them because this is a string array. All right, and if we try to print that out, if we cycle through the array without having this if statement, we're going to see some blank lines. Okay, so it's going to print all these out, but there's going to be blanks for 1 and 3. So instead of having the blanks show, I decided to just show you an example where I could say, if names at the current index is not equal to null, then we'll print it out. So null is a new keyword. We haven't seen that before. Okay. So basically it just means, so null means that a string, like a string variable, hasn't been assigned something. That's all it means. So it has no assigned value. So if what's stored in there is not equal to null, in other words, it's been assigned something, we'll print it out. If it hadn't been assigned something, then we just skip it and just, continue with our loop. All right. Now here's a new, we haven't seen this yet. So this is another way to declare and also at the same time initialize your array with values. All right. So we just start out the same. So string brackets names is assigned new string brackets, but this time we don't put the number in the brackets. Okay. We actually can, but it's not normal. It's not convention to do so. Okay. We could put a number in here, but we don't. The reason why we don't is because we've got an initializer list out here. This right here. So to do an initializer list, we're going to do curly braces, and then we're going to do each value separated by commas. So this is going to be element, or at index 0. This is going to go at index 0. This is going to be stored in index 1, and so on and so forth. Anybody know why we don't have to put the number inside the brackets? Anybody have a guess?
Because then it will let you just keep adding things to it?
You could keep adding things to it, yeah.
As long as you need them, at least?
Yeah. Well, the reason why you don't have to is because C# says, well, there's 1, 2, 3, 4, 5 things in the initializer list, so I'm going to create a 5-element array. All right? So it knows how big to create it. And, yeah, if you put the number in here, like if I put 5 in there and I started adding elements in here, well, I'd have to also change the number. So like if I added another name, whatever. So that's 6. If I just leave it like this, it'll automatically create a 6-element array. However many elements you add, it's going to figure out how big your array needs to be. Okay? So you can do it either way. You can do an initializer list like this, or you can do it the way I showed you up here, where you initialize them, individually by hand. Just different times call for different things. And then let's see. Again, I'm just cycling through and printing the values out, just for demonstration purposes. Now this one is like the previous one, but notice how. Let's see. What's the problem with this one? Okay, in my loop, right there. That 5. What if I add elements to this, or add values to this initializer list? I'm gonna have to go in and change that number, right? It's not gonna. It's hard coded. That 5 is what we call hard coding. So if I add 2 more names, that's 7 things. I had to come here to change this to 7, so on and so forth. But with arrays, there's some neat things we have with arrays. One of them is the length property. Right here. I less than names.length. Length is a property that keeps track of the length of the array. Right? So we just give the name of the array and then dot and then length. Right? So for this array, length is going to store 1, 2, 3, 4, 5. Right? So if we add elements, length is automatically going to be updated. Do you see the advantage there? Whatever I add to here, this is automatically updated. I don't have to change it. Okay? So remember that with arrays, you have length. Any questions? Does the weather have everybody down? Is that what it is? All right, let's see. Now here's another one using doubles. All right, so I got an initializer list, 1, 2, 3, 4 values. So I'm going to create it's going to create a 4-element array. And yeah, so notice these are well, that's an integer, but it'll be treated as a double. There's a double, so on and so forth. Let's see, in this program, let's see, so we're declaring variables total and average. So we're gonna, actually, so this is the grade calculation program, like we've seen before. So we're gonna go through using a for loop as long as the index is less than grades.length, okay, which is 4. And what we're going to do is say total becomes its current value plus grades at I. We've actually seen this before when I showed you my solution to that grades program. So the first time through, total is 0, right? So 0 plus, and then grades at 0 is what? So right here, grades at index 0 is what? The first, well, what is it? 100. So the first time we're going to say 0 plus 100 is assigned to total. Everybody remember that plus equal assignment? Okay. All right. So what we're doing is we're just creating a running total as we cycle through that array. And then finally we come down here and say average becomes total divided by, and look what I did here, grades.length. Okay, so grades.length stores the total number of grades. So we can use that to calculate our average. Again, notice if I add more things up here, this and this are automatically updated. I don't have to change them. So hopefully that makes it clear why you want to avoid hard coding things. And let's see, finally I'm going to come down here and print the average using string interpolation, and I'm going to do to 2 decimal places, print out average to 2 decimal places. All right, this is a neat one. So this program copies one array to another, and it does not change the original array. So we're going to create one array right here. We've got array 1. That's an array of doubles with an initializer list. You don't have to. I mean, that's just the way I did it. And then we're also going to create a second array. So we can create as many arrays in the program as we want, by the way. And they can all be of different data types. Now, a single array can only hold one data type, though. So we can create an array of doubles. But if we want to also store, say, strings, we've got to create another array to hold strings. All right? So a given array can only hold a single data type at a time. All right, so we create a second array, but look what I did here. So normally I'd put a number in there for how big I want the array, how many elements. But here I put in array1.length, so it would be the same exact size as array 1. Whatever size, I mean, however many things I add to array 1, this will automatically update and create array 2 of an appropriate size. Everybody see that? Okay. So I don't have to put a number in here to specify the size of the array. I can do things like this, like this property. So at this point in the program, I would have 2 arrays of the same size. One has values in it, and one is empty. Array 2 is empty. So to copy the contents, so again, I'm going to cycle through with a loop, starting at index 0, and going into as long as I'm less than array1.length, right? And then I'm just going to say array 2 at I is assigned array 1 at I. Remember, array 1 has values in it. So array 2 at the current index is assigned whatever value is stored in array 1 at the current index. We keep on, and when we get through that, we'll have 2 arrays with the exact same contents. Okay? Why am I doing that? Again, just to show you an example. But one thing this is useful for is, like, I might want to make a copy of an array so I can change values in the array and still keep the original contents for some other purpose. Okay, so that's one practical application for that. Again, have 2 arrays that start having the same contents, then I can change one array, and the other array has, the original contents. Let's see, and then down here I'm just going to cycle through the arrays, print out the values. No big deal there. By the way, curly braces. Why did I put those curly braces there in this for loop? And I didn't put them here. Why did I? What's going on there? All right, I'll tell you. I put the curly braces here. They're not required, are they? They're not required. But with my comment in there, it would look kind of strange without them, right? So I just put them in there to make it look nicer. And of course here, I don't have to have curly braces because I've only got one statement inside, okay? All right, so here I'm just creating an array again. All right, so anyway, in this for loop, so I'm just assigning, again, the indices. I'm just storing back in the array, all right? Now, notice to store stuff in the array, I need an index, all right? I need an index that I can put there in those square brackets in order to store stuff. I can also use that index to print stuff back out or you know, whatever, to access the value stored in that element. We've got another type of loop, though, the for each loop. So we haven't seen this yet. This is particularly useful with arrays, and here's how it works. So we have the for each keyword, followed by, this isn't really a condition, but it's parentheses. So it's always going to have a set of parentheses after it. And it says int num in nums. So nums is the name of the array. So that's always going to be the last thing. And you're also going to have in before it. So that's another keyword as well. That's why it appears in blue. Over here, I'm going to declare a variable, or I'm allowed to declare a variable. And it's going to be, the data type for that variable is going to be whatever the data type is of the array. And the name of that variable is normally going to be the singular. It's common to have it be the singular of the array. So notice I named it num, and the array is named nums. If I had an array called names, I might have a variable called name. Or if I had a variable called grades, I might have an array called grades, I might have a variable called grade. So on and so forth. So what it says is for each num in nums. So what it's going to do is it's going to go through the array automatically starting from the very first element. And so starting with the first element, it's going to copy that value into num, and then we can do something with that. The second time through, it's going to go to the second element of the array and copy it in num, and we can do something with that. So each time through, it's going to automatically copy the current element into this variable so we can do something with it. All right, so that makes sense? So for each num in nums, we're going to come in here and we're just going to do a write line to print it out. All right, now the one thing about this is, notice there's no index. It doesn't show an index, it doesn't allow us access to an index. So we can't really use it, we can't directly use this type of a for each loop to do something like assigning values. Anything where we have to have access to the particular index, well, it's not as easy to use for each. So it's suited when we just need to go through the loop, through the array and do something like this, printing out values. Okay? If you want to assign values, if you need access to the index, then you could fall back on a for loop, or a while loop, or a do while loop. And let's see here, we're doing a string array, so we can use for each for any type of array. So for each name in names, see how that reads in English? It makes total sense. Then we're going to just do a write line and print out name. All right? We don't have to just write out the name. We can do all kinds of things, whatever you need to. Just a simple example. This program allows the user to enter an array index where they want to store a name. All right, so this is a little bit more advanced. Let's see, what I'm going to do here is I'm going to create an array called names to store 5 different names. I just chose 5, it could be whatever you want. And then I'm going to create a variable to store an index. Hence, it's going to be an index for our array. So far, we've used I, because that's pretty common in for loops to use an index of I. But we can actually call it whatever we want. So here I'm creating one that actually has scope in main. I'm not creating it inside of a for loop or anything. Okay, we talked about scope last time I lectured.
And then I'm going to go in a do while loop here, all right, right here. And in this do while loop, I'm going to prompt the user, enter an index 0 through 4. Of course, I said 0 through 4 because I created an array of 5 elements, right? Or they can enter -1 to quit, right? To quit entering stuff into the array. All right. So I'm going to get the index. All right. I'm going to get the user to print or type it in, and then store it inside index. And this right here, this if statement says, all right, if index is valid. In other words, if index is between 0 and 4, because anything else is invalid, right? So if it is valid, then I'm going to prompt him to enter a name. I'm going to read that name in and store it in my array. Because if it's not valid, I don't want to do that. Everybody see that? So if index, so this says, we can write it like this, 0 less than equal to index and index less than or equal to 4. So that's the valid range. Then we enter a name into our array. Okay? Now, so we do this as long as index is not equal to -1. Why? It's right there. I told the user to enter -1 to quit. So as long as they don't enter -1 for the index, we're going to keep doing this. As soon as they enter -1 up here, notice if they enter -1, this will be skipped. We won't enter anything into the array. We'll come down here and this condition will fail. So we'll jump out and come into this for loop. And again, this for loop is all we're doing. Let's see. I should have used the array length here. I hard-coded this. I should have used array length. Anyway, all right, so we're just going to cycle through it. And then if names at the current element is not equal to null, okay, as long as they, so again, the user is choosing the index where they want to enter a name. All right, so they may quit before all the names are entered. So we don't want to print out any null values. We only want to print out where they actually entered something. So that's why, again, you know, the example we saw before, where we're doing something as long as the value is not equal to null. That's what that's about. Does that sort of make sense? So again, that program will let them enter a name at any index that they choose, any valid index that they choose, right? And they can enter as many names as they want. They don't have to enter 5. You know, they could enter 0. They could enter 1, 2, 3, 4. Okay?